This is the solution for the question 2 of homework 11 from Hw11. And first, we look at this question 2 first. It told us that it gives us three functions v, and it wants us to find that whether it can represent an autocorrelation function of a WSS statistic process, or whether it can represent a spectral density function. It is very easy, and we should notice the property of autocorrelation function and a spectral density function first. As we all know, for autocorrelation function, if it is an autocorrelation function, it must be an even function, and it also should be, this function should have the maximal value at 0. So the f0 must be the greatest, and also for this, and its Fourier transform must be non-negative. So the three conditions satisfied, it can be a autocorrelation function. And for the spectral density function, it is much easier. If this function is non-negative, then it can represent a spectral density function. It's the necessary condition of a spectral density function. So first we look at this first function. We verify it's first. So to see whether it is a autocorrelation function, first it is a even function. From this this function we can know that, and we also know that its maximal value is at the 0. So the first and second condition satisfied. And for its Fourier transform, we can get its Fourier transform in this form, and we know it is non-negative. So it can represent an autocorrelation function of WSS. And for whether it can represent a spectral density function, so we verified in this form it is non-negative, so it can represent a spectral density function. And for the second function, first we can from its form, we can know that it is even. It is even, and its greatest value is also at 0. So the first and second condition satisfied. And for its Fourier transform, we can know that this transform also greater or equal than 0. So it can be an autocorrelation function. And for its spectral density function, we also know it is non-negative, so it can be a spectral density function. And for the last one, it's like a even distribution form, and it is easily to know that this function is even, and its maximal value is f0 is its maximal value. So the first and second condition is satisfied. And for its Fourier transform, we also, however, it doesn't always make sure that it is greater than or equal to than 0. Sometimes it can, because this sign function can be negative in some omega, so it doesn't satisfy, so it cannot be an autocorrelation function. And for the spectral density function, because it is non-negative, so it can be a spectral density function.